So until now we have modeled the holding structure. We have defined the load patterns, load cases and load combinations, and supports and releases. After that we need to analyze and check the model, that whether there is some modeling deficiency in the structural model. So it is showing that model has been checked, no warning messages were generated. And after that we need to check the advanced sapphire option. Right now we used advanced solver and analysis process options as auto. And after that we need to check for set load cases to run. Here we can see that eigen model cases are defined. So what we can do here is that we can define the model cases as of grids, and we can set them to be acceleration ux and uy. To be 99%, and we can 12 number of modes is sufficient for this type of structure. After that, when we are analyzing the structure, so we need to check that whether the structure has run into any kind of instability or not. So we need to go to analyze and left click on last analysis, run log. So here we will see that it is showing that the structure is unstable or ill conditioned. So check the structure carefully for inadequate support conditions or one or more internal mechanisms, zero or negative stiffness properties, extremely large stiffness properties, buckling due to P delta, or frequency shift on to natural frequency. So it is showing that to remove this instability, we should use the standard solver or run an eigen analysis using auto frequency shifting and investigate the mode shifts. So what we will do is that we will analyze the structure with the standard solver. As this is a very small structure, so what we can do here is that we can go to analyze and advanced sapphire options, select standard solver, and then again analyze the structure. So here we will go to again last analysis, run log. So here we will see that it is showing that numerical problems encountered during equation solution. That is, the problem is coming on the joint number 61 and 60. So these two joints are basically giving us the problem or giving us the instability. Joint number 60 and 61, it is showing the degree of freedom is Rz along z axis, and x coordinate and y coordinate and z coordinate is given, and the deformation is approximately in the range of e to the power minus 10. So this is like an instability, and what we can do here to remove this instability is that either we can delete this arrangement and model them again and check that whether the desired arrangement is correct or not, or what we can do here is that we can just hide this shell object, make selected objects invisible, and then unlock the model, and then simply delete the structure. And what we can do here is that we can just press Ctrl C, Ctrl V on your keyboard. Now this distance is 3 meter and this distance is 0.8. So we enter delta x as 3.8 meter. Left click on OK. And after that we need to model these vertical members. These vertical members are ISA 150, 150 and 10. So we can draw beams by this option also. We select the property as ISA 150, 150, 10. And draw these beams. These members are ISA 75, 75 and 6. And we need to assign releases to these members again. assign frame and releases partial fixity. We need to assign releases to these members also. We go to assign frame and releases partial fixity, and then left click on apply and OK. And then again we check for this instability. We go to analyze and last analysis run log, and then it is showing that the structure is again unstable on join number 55. So let us check that where exactly is this join number 55. This is the join number 55 and it is showing the instability. What we can do here is that we can check the releases here. Press Ctrl plus W on your keyboard. So now we go to analyze and run analysis. We go to analyze and last analysis run log to check it with whether the structure is now still unstable or stable. So we'll see that there is one more instability here on join number 55. So let us check that what exactly is the join number 55. Press Ctrl plus W on your keyboard. Select object assignments and unique names. So here we will see that joint number 55 is this node. So maybe the joint is being released on 2 points. That is why it is showing instability. So as a trial and error, what we can do here is that unlock the model and do not assign any releases to this member. So we go to assign frame and releases partial fixity, no releases, and apply and OK. And after that we need to again analyze the structure and check that whether the instability is still there or not. So we go to last analysis run log, and yes, here we see that the instability is now removed. So it all depends upon the your engineering judgment that what exactly can be the problem in our structure. So this is a deformed shape under the dead load, and we can also check the model shapes, which should be very bizarre in this type of cantilever structure. So this is the first mode shape. First mode shape is itself torsion shape, and second mode shape is this is like this, and third mode shape is like this, opening and closing. And our fundamental time period is approximately 3.678 seconds. So in the next lecture we will learn how to design this steel structure.